My name is Marco. I'm a member of the FOSSASIA group, but my day-to-day job involves robotics. So I'm part of Intrinsic, which is a startup in robotics, and a lot of us at Intrinsic intensively work in this project that is very popular in robotics, that is called the Robotics Operating System. And today, because FOSSASIA is a bit of a force open wide type of conference that's not specific to any topic, I like to always try to formulate my talks in a way that we include everyone, so it's not like very specific to the robotics community. So if you have a lot of knowledge about ROS already, then you might find this a bit, I mean, it's still a bit interesting. I find it interesting because I'll go through the story of ROS, which a lot of people that is heavily using ROS these days don't know. But it's a bit of the story of how free and open source software has actually put robotics at the place where it's at today, right? So that's what I like to enforce in this talk, is that the place that robotics is today is in many ways just thanks to free and open source software. So this is a bit of the story about that, about of the Open Source Robotics Foundation, which is the foundation that oversees the main projects in robotics, the main robotics open source projects that are out there and have been used by a lot of people, and how it all got started, right? So this is a picture. This is a GIF of the core. This is only the core packages that we have at the robotics operating system, ROS. And this is like how many people are contributing through the years, right? So the project is insanely huge. So I would say, I would adventure to say, is one of the biggest open source projects out there. It is federated in a way that all these guys, so this is only the core packages. There's many more packages that are not here. So it is federated. You can think of like in the same way that a Debian project has different packages. So we also have different packages, and not all the packages that are available out there are actually represented here, because this is only the core. So you can go out, do your own package, put it whatever you want, and we might not even know about it, right? But we still can consider that part of the ecosystem, right? So there's the Open Source Robotics Foundation steers these projects and steers this robotics community through four main projects, and the most famous one and important one is ROS, with the new version being ROS 2, and the second one is Gazebo, which is the simulation. So in robotics, we need simulation. A lot of like it's something that is like heavily needed. So we rely a lot on simulation. Then one of the latest projects is OpenRMF. So OpenRMF is an interfleet robotics management system. Not only robotics, but also infrastructure. So basically the problem that OpenRMF is trying to solve goes a bit into the future. That's why it's a bit of the newest project. And it's basically when you have many different robots from many different vendors, and you need to control this fleet of robots and have them interact with each other and solve tasks within an infrastructure, right? So for example, let's say this university, you might have delivery robots, cleaning robots from different vendors, from different fleet managers and all that. And you need them to talk to the elevators, you need them to talk to the doors, you need to integrate all that, right? So OpenRMF is the software that is doing that for you, right? And then finally, this is something that has always been there, but we are the foundation is starting to take it way more into account, and it's the infrastructure, right? So it's not a project per se, because you don't use it in your robot in the end, but it's a project as we see it, because we have to put resources into it, and it basically means like all the infrastructure that is behind these projects is built by the infrastructure project, right? So we have build farms, we have websites, we have documentation. All this is managed by the infrastructure team, right? So I'm going to go through these projects. I'm going to explain what they are, give a bit of an overview. Our next talk is 2:15. So we have a bit of a room here to roam around. Afterwards, we can talk, we can have questions, however you guys want. We have the room for the robotics for the entire day, so we don't have to worry about more people coming in. After Yaru, my colleague Yaru will come over. He's talking a bit more of the intrinsics about ROS, so I'm not gonna talk too much about it. But I'll just give you guys an overview of ROS because it's the main project that has been out there, and you guys might know better about it. And I don't know what just happened. Did this go off? Really? Oh no. Okay. I think this is a video. Okay, let me. Yeah. Oh, there you go. It was starting to load. Okay. So this is a small video. I just want to play it out. It's a 2 minutes video. It's an introduction of four video series that the Red Hat guys made about ROS. And if you guys are more interested, you can go onto YouTube. It's very nice. It explains how it all got started and all this, like all with very much good editing, so much better than I can do it here. So if you guys have some time, I think it's like 10 minutes each, but this one is just the intro, so I'll just play it for you guys. If I can. Is this working? I'll just let me just tell you the story. There was a lot of confusion in the robotics community, and everyone just had to start over every single time. It takes years to implement robotics or even small capabilities because essentially you're starting from scratch. And if we could up that, if we could create the common platform that we all build on, the world would just change. Was this really kind of strange place, just strange enough to be able to bring community together. And it looks like people are having so much fun to be doing serious work. It became the follows of the it was a research lab, it was a research development lab. It was to make robotics better as fast as possible. Stands for robotic system. I mean, it's going to be careful with too many things. I think of it as the stuff in order, so we can refer to it as the calling. We brought and provided everybody else the best and great stuff. That's a really beautiful idea. And that idea is teach them and then you say, go back to school and work on robots for us. And that's what kind of happened. Everybody's building on and contributing to really be able to build each other without bringing the communities together. So yeah, so the series is called "How to Start a Robot Revolution." If you guys you look it out on YouTube, you can see the whole series. So yeah, again, the problem that was happening in robotics at the time everything got started. This time there was not much industry involved. It was more like a research lab kind of thing, and every single lab was doing their own thing. You go as a PhD student, you're like, oh, I have a great idea. I'm gonna build just another tool to make robotics the next big thing, right? And then you have 99 problem plus one. You got another tool into the ecosystem, right? And that's when Wheel Garage got started.
So these got started in the Silicon Valley area, very related to the Google guys. You probably saw Larry Page there. They started this sort of like research lab towards industry kind of thing. And they started this platform that is called PR2. So this was like a very bulky robot, but it was started as the first project for them. And they realized, oh, we need something to run on this, right? What do we do? So they said, let's put an operating system into it. So that's where the name comes. As they said, it's not an operating system. It's basically a framework that runs on top of a Linux, which is the real operating system. But this was sent out to a lot of research centers. And a lot of students, there was a heavy internship program that brought a lot of students to Willow Garage. And then when these internship students, like many of you guys here, started working into ROS, they went back to the universities and they say, hey, there's this amazing platform that we can work on that gives you the basics for everything, and then we can build on top, so we don't have to worry about every single thing that comes at the bottom, right? We can just focus on our research. So that put out there very good and state-of-the-art packages that everyone could use, right? And robotics is not like it's something that someone can do on your own. So FOSS becomes relevant here because you need expertise from many fields, right? And universities are a good example of that, because you have the department that is doing AI, you have the department that is doing perception, you have the department that is doing navigation, and you want the best of all of them, right? So the FOSS ecosystem is allowing you to actually have the best of all of them and put them all together and contribute in the part that you're actually an expert, right? So that's how it all got started. It all got started through the universities and research, right, at that time. And as the software started getting more popular and the software started getting grow a huge community, the Open Source Robotics Foundation was created. So the Open Source Robotics Foundation is the actual owner of these projects and is the actual steer of the community towards maintaining and developing these softwares forward. So what does ROS provide, right? So ROS is an entire ecosystem, and it provides what we call the plumbing. So in robotics, we build things with different nodes, and they all connect together. There's a certain communication that happens between these nodes. So that is what we call the plumbing. Then we also provide the tools. So the tools like RViz, like visualization tools, simulation tools, all this is also provided in the ecosystem. Then you have capabilities, which, for example, I was saying before, like SLAM navigation, or the AI algorithms, perception, all these are also part of the ecosystem. And the open source ecosystem in which you can leverage on, right? So there's Q&A forums that we have, and people can come ask their own questions, documentation. There's a discourse where people can get integrated into the community, right? And I'll go more into detail on how people here can get more involved into all these projects, right? So ROS started in 2010, and there's been many versions of ROS. But then, as I said, the story of robotics has not always been research, right? Has not only been on the university. So there was a time where there's started to shift, and industry started to say, hey, this robotics thing is something we can use, we can leverage on, we can make some money out of it, right? But this ROS one is not ready to put it in a product. We need something more stable. We need something more consistent, something we can put out there, right? So that's when there was a need to change, and that's when we came with ROS 2, right? So ROS 2 has also been around for quite a few years. So these are the releases that we've been doing. Now it's trying to stabilize releases every May of every year. And our latest release is in May 2023, which is IDEN. And then the next release is happening this May, which is called Jazzy. Then there's also a rolling release, which is basically the release where we put everything that is the latest and the greatest, and also the less stable. But at the same time, this release allows us to just basically, we use it as a fork for the next release, right? So there will be a point in time where we just use rolling to basically create the new release. So we can actually, that allow us to put a lot of packages ready to build, ready to use from day one on our release, right? So May 23rd, you will have all the core packages at least ready to use in Jazzy. So a bit of on the architecture. I'm not going to talk too much because Yaru will probably talk a bit more. But the biggest change that happened in between ROS and ROS 2 was at the communication layer. So there was so of course you have the hardware, you have an operating system, then you run the framework on top, and then you build nodes. So that hasn't changed. So you have nodes that talk to each other, and then at the communication layer, basically the idea that you can think of is in ROS, we had like a ROS core thread that was in charge of this communications between these nodes, and that was becoming a point of failure. And then the approach that the developers brought in is to use something called DDS, and basically at this layer we have now ROS abstract middleware that allow us to use different implementations of this DDS, right? So DDS is a standard, and there's many implementations of this standard that can be easily changed just with an environment variable. How does these nodes communicate? So we have different nodes that talk to each other. So you can think of this. I have a camera, and I have something reading the camera images that I want to use, right? So my robot has a camera on top. Then I create a node that is a publisher. Then I put a topic, camera 1, and then I have another node that is reading this topic. So basically in this message, I can send the images that my robot is seeing, right? So in the same way, you can have this publisher subscription way. You can have more than one subscriber. So this, you can have like someone publishing the images, and then you can have the subscribers reading the images. But you can also have more than one publisher. So it can get as complicated as you need, or it can get as simple as you want it to be, right? Then we have something else called services. So basically a service, you can think about it of like calling a remote function. So basically you make a request, and then you wait for the response to your request, right? So you can use this in different ways on your architecture. In the same way, you can have more than one nodes asking for a service. And then finally we have actions, which is a bit of a mix, right? So in an action, you will request in a similar way that you do a service. So you request for an action, you get a response. So this is like, you can think of it like a more long-term goal, and then you keep getting a feedback from the node. So you can think about it like, okay, my goal for the robot is to go to that table. So you say, go to the table, okay, I'm going, and then you keep getting feedback that the robot is still going and nothing happened. And then you can also send a result request at the end, right? All right, so ROS these days is actually empowering so many robots. So you can find many. This is just like a small snippet of all the robots that you can, and they range from everything You get like autonomous cars. You get the Baxter. You get like NASA robots, powered robotics, whatever. Like whatever you can think of is running ROS these days. There's also, as I said, with the new introduction of industry, there's also a lot of money coming into the ROS ecosystem. There's a lot of companies that are running many venture based ecosystems, and they have a lot of funding into their ventures. Also, I wanted to mention ROS has, as I said before, robotics has many topics, and the way the ROS ecosystem works is through working groups. So whatever your main interest is in the robotics field, there's many different working groups that they have meetups online. You can join. You can join their projects and you can work on whatever they're working, or even ask whatever you want. And that gets us to the next project, which is Gazebo. So Gazebo is basically the simulation. In robotics, we don't want to test the first time everything in your robot, because it might be something that you send into the moon and then you don't want to crash because that's a lot of money. Or it might be something that you are driving on the streets, such an autonomous car, and then you don't want to kill people, right? So we do a lot of simulation, a lot of simulation, and the way Gazebo is structured is basically so it's in the form of libraries. So you can use the entire system as a simulation, but then at the same time, all these libraries can be used independently, right? So this allows users to interchange different things, like the physics engine, the rendering. You can create plugins. Is very flexible, right? So it's done in a flexible way. And as I said, the key thing that we have with Gazebo is that it interacts with ROS in a very easy way. You can use it with ROS, but you can also use it on your own. So it's not mandatory to use it with ROS. But basically the idea is that you build your ROS nodes talking to each other and all that. And then, so you have your simulation, and then basically using the same code, you can just translate it into your robot, right? So you have a similar model as the one on your robot. You have a simulation of your environment, and you can basically do a seamless swap from simulation to have a bunch of assets, and they sort of try to represent the features that are shipped with this version of Gazebo. So we try to put all the features into these worlds. And then another tool that I didn't mention before that is part of the Gazebo ecosystem is Fuel. So all these worlds, you can find them in this. It's sort of like a repository for models and worlds. So you can see you can find UR robots there. It's actually very useful because all these models, they are already there for you. And you can also find the worlds that we do. And then that brings us to OpenRMF, which, as I said, is this multi-fleet management system that helps coordinate these fleets into certain infrastructure. And it helps you, as I said, it helps you manage different fleets from different vendors. And the main features that it has is, one of them is task planning and allocation. So basically you have tasks, and you want to plan them in time, and you want to allocate them to fleets. So you can use OpenRMF for that, and it will take care of that, right? And then fleet traffic, which is also a big problem, especially when you have many fleet managers, and you can see the robots have to stop to let the other robots go in. Like sometimes you have small alleys, so it can become. So this is all transparent and is being done by OpenRMF for you. Integration with the infrastructure, as I said. So door, lifts, the robots have to call and have to call lifts, have to open doors, and OpenRMF will take care of that. And interaction with work cells. So a work cell might be doing certain tasks like In this case, is serving a can of Milo to the robot, and then he'll bring it to somewhere else. But it could be anything. It could be some operating theater robot that is doing something and putting some objects in the robot to deliver somewhere else, or blood tests or whatever. And then there's an entire toolbox that you can use. So one of the key ones, you got simulation tools. The traffic editor is a tool that helps you design the floor plan with all the pathways that you'll need for the robots to move around. And you can also convert that into simulation environments that you can use for your simulation of the entire ecosystem. And with this project, there's been a lot of assets that have been released. So also assets that are useful for OpenRMF, you can find them in Fuel. So in the repository that I mentioned before from Gazebo contains all these assets that can be useful for simulations with OpenRMF. And that brings me to the last project that I was talking about, which is infra. So basically, it's hard to see, but we're starting to consider this as a project because it takes a lot of resources. So I wanted to give it a bit of a time here. So basically, infra is the project that makes sure that packages are being built, CI is being run, and web pages are maintained and all that, right? So far we use Jenkins as our build farm. The infra guys, they always like to say that I think up to our knowledge is the biggest Jenkins instance that has been running out there. I don't have the numbers, but we build a lot of packages. I don't know if it's here somewhere, but yeah, it's continuously running a lot of CI jobs. We do this for ROS, so you can see all these crypto words are basically our releases. So this is Iron, you get Humble, Rolling, and they have all the packages being built constantly and put out there in Debian repos for everyone in the community. Same for Gazebo. We have a build farm for Gazebo. We also have the repos, and this is the status page where we can check how the repos are doing, what packages are where in testing or already being built. And last, I wanted to talk a bit about the Open Source Robotic Alliance. So Open Robotics came out of there was a company that was bought. So all the developers are now in Intrinsic. So the foundation came out with the Open Source Robotics Alliance, which is basically in a similar way to the Linux Foundation. There's more explanation here, the entire ecosystem, how it works. But basically what it has is a bunch of companies can become members. On the financial side, they just have a membership fee. Also, individuals can become members, and all this, they can help steer all these projects. And at the same time, there's another approach where technical developers can become developers and you can think of that as a similar way as the Debian developers do it. So there's a process that is being put in place. This is very recent, so it's still not 100% yet in place, but the idea is that you can start collaborating, and there's a process where you actually become a ROS core developer, Gazebo developer, OpenRMF developer. So it's open to everyone. As I said, the Alliance will provide funding and steering and guidance for all the 4 projects. And I want to give everyone a bit of guidance on where to start. So for ROS, we have the main ROS website. We have the index where all the packages information is listed. Then we have answers, which is basically a Q&A website where you can go and ask your questions. And then we have Discourse, which is the forum, which is where all the announcements happen, discussions, everything related to like governance and also like talks that are happening, events, and all that. They all got posted in this course. Similarly, for Gazebo, there's a similar structure. We got Gazebo Sim, which is the website, and then we got like also Q&A, and then the community Gazebo Sim is the discourse, which is where all these things get posted. And then OpenRMF also has their own website. Still, most of the stuff is still happening in GitHub, so you guys can go to GitHub. This is a book that contains a lot of the documentation related to OpenRMF. Some of it might be outdated, so just putting that out there. But the key concepts are there, remain the same. There's a lot events happening all around the world. ROSCON is the biggest one. It's a lot of fun. If you guys ever get involved into the community, it's a lot of fun to go to ROSCON because you can see all those people that you've been talking to online and put a face to that picture on GitHub. There's also local community events. I put here our next ROSCON, which is happening in Odense, in Denmark, in October this year. But as you can see, there's ROSCON. We had ROSCON Kyoto, Macau, Japan. So it moves around the world. There's also local ROS meetups. So we have in Singapore, which is where I stay. We have our meetup in Singapore, but there's meetups happening in every single part of the world. So this course again is probably the best way to get into that. And yeah, so the best part, swag. These cool t-shirts. Every time we put out a release, we open up a shop with all the new t-shirts and designs that are available for a limited amount of time while the release is alive. And you guys, this is for Gazebo, this is for Ross, and people can go buy them, support the foundation. But also there's a tutorial party that happens, I think the next tutorial party should be out in a couple of weeks. Will be first week of May, I would say, if things go well. And the tutorial party means there's a bunch of issues that we put on GitHub. People just go test them. If you're on the top 10 that test them, then you get some swag for free. So that's pretty cool. Gazebo guys, they do the same thing. So just stay tuned on their discourse for announcements. And yeah, thank you very much. If you guys have some questions, if we don't have time, maybe we can chat around. And yeah, thank you very much.